The voice is lagging.
Okay, basically, this is a topical paper for mass spectrometry, or like this is a question like we have discussed fragmentation yesterday. So they are saying the mass spectrum of pure 3-methyl butane 2-on is shown. State how you would find the molar mass of 3-methyl butane 2-on from the mass spectrum. So basically, in a mass spectrum, we have few peaks. One of them is molecular ion peak. One of them is molecular ion peak, represented by M plus. Represented by M plus. This is molecular ion peak. Molecular ion peak is going to tell you the overall MR of a compound, of an unknown, like of the given molecule, that is going to be analyzed through mass spectrometry. In this question, this is 3-methyl butane 2-on. So they are saying state how you would find the molar mass of 3-methyl butane 2-on from the mass spectrum. Like I told you, molecular ion peak is going to tell you the molecular mass, is going to tell you the molecular mass. Now the question is like where the molecular ion peak is. So remember, molecular ion peak is on your extreme right hand side. On your extreme right hand side, right? Or you can say that the peak which is having a largest mass, the peak which is having a largest mass. Like let's suppose this is a peak which is having a mass that is, I think so, 15. This peak is having a mass, you can count, this is 21, 22, 23, 24, 25, 26, 27. So this peak is of 27. And then if you count, this is 40, 41, 42, 40. So this peak is of 43. So in this way, you can determine which peak is having highest molecular mass. So this peak is having highest molecular mass. Can you tell me what is the molecular mass? Can you tell me? I'm zooming in. What is the molecular mass?
86.
This is 81, 82, 83, 84, 85, 86. So this is 86. So basically, state how you would find the molar mass of 3-methyl butane 2-on from the mass spectrum. So we are supposed to write that. The peak which is having largest M by Z value. This is M by Z. M by Z means molecular mass, okay? Which is, that is 86. Let me justify this. 3-methyl butane 2-on is this. 3-methyl butane 2-on is this. Methyl butane 2-on is this. So can you tell me the molecular mass of this compound? Yes.
Molecular mass of this compound.
Yes.
Molecular weight.
Like how many carbons are there? You will say 5 carbon atoms, C5. How many
you mean
hydrogens
molecular
are there? 1,
formula.
2, 3, 4, 5, 6, 7, 8, 9, 10. And O, C5H10O. Can you tell me the molecular mass?
Molecular mass. Okay. You mean molar mass or molecular mass?
Yes.
Okay, 1 minute. Is it 86?
Is it 86? Yes, this is 86. So as you can see, molecular ion peak is going to be the same, that is 86. So that's why we can say that if I'm going to tell you that this is a molecular ion peak which is at 86, it means that the molecular mass of a compound is 86. This is the reason we say that molecular ion peak is going to represent the overall molecular mass of a compound. Are you getting my point?
Yeah. Yes.
Good. Good. See this. The mass spectrum shows a peak at mass to charge is equal to 43. Draw the displayed formulae of two fragment ions that might be responsible for this peak. You know, I told you the fragmentation pattern for water, like, you know, the compound is 3-methyl butane 2-on. This is your compound. This is your compound. And they are saying that after fragmenting this molecule, this compound, after fragmenting this compound, it's going to give a peak that is at 43. That is at 43. 43. So what is 43? First of all, you have to make a compound. First of all, you have to draw the structure of a compound. Then you have to break it down in such a manner that it should be fragmented into the component which would be having the molecular mass that is equal to 43 basically. Okay, so first of all, I'm going to draw the structure. First of all, I'm going to draw the structure just like this. See this, CH3, like I have drawn over here, CH3, C double bond O. Okay, then we have so this is the structure for 3-methyl butane 2-on. Okay, I'm saying that this compound is going to be fragmented over here. This compound is going to be fragmented over here. Okay, so
Yeah.
I can say that it would be like broken down into two pieces. The first piece is this CH3, C double bond O, positive. Why I'm going to write it positive? Because, you know, in mass spectrometer only cations are determined. I told you, like, we generally enter the compound into the mass spectrometer. Firstly, the compound is vaporized. Then the compound is ionized. Ionization means the loss of electron. After removing electron, your compound would be converted into the cation. So remember, whenever you are going to fragment the molecule, so you are supposed to write in the form of cation. So the second piece is just like CH3 and then CH3, like this. CH3, CH3 and H, and this is a positive sign. Okay, now you are supposed to find out the MR. Now you are supposed to find out the molecular mass of these fragments. Can you tell me what is the molecular mass of this and what is the molecular mass of this? Yes, you have 2 carbons, 3 hydrogens, and this 1 oxygen, and this is 3 carbon atoms, 6 hydrogens, 7 hydrogens, and positive sign. Okay, yes.
Hello, sir. I cannot hear you.
Sorry.
Hello.
Yes, what are you saying?
Oh, yeah, I can hear you. Did you say anything?
Yes. I'm saying that, can you tell me the molecular mass of these fragments? Yes, fast, 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 fast.
Molecular mass of the ions.
Yes, exactly. So
Okay.
2 carbon means 2 into 12, 3
Yeah.
into 1, and 1 into 16. So what is in total? 3 into 12, 7 into
43.
1. So this is 43, and this is what?
This is 43 as well.
Okay, so they are saying that they are asking, draw the displayed formula of the 2 fragment ions that might be responsible for this peak. So yes, we have drawn this, but they are saying you have to draw the displayed formula. You have to draw the displayed formula. So I am going to draw the displayed formula in such a manner. If you can see this, you have 3 hydrogens which is connected to carbon. This is oxygen, and this is positively charged carbon with 1 hydrogen, and this is 1 carbon is having 3 hydrogen atoms, and also you have 1 carbon which is having 3 hydrogen atoms. So these are the fragment ions which are going to be produced if you are going to fragment, if you are going to break down this compound. Are you getting my point? Okay.
Yeah.
So this is another question. They are saying the mass spectra of the 2 isomers of dichloroethane are shown. Let me tell you what is dichloroethane. So basically, 1, 2, you have 2 carbon atoms, and you have dichloroethane just like this. This is
Yeah.
dichloroethane. So they are saying the mass spectra of the 2 isomers of dichloroethane are shown. Can you tell me another isomer of this? Obviously, it would be just like this. This is 1,1-dichloro. This is 1,1-dichloroethane. This is 1,1-dichloroethane, and this is 1,2-dichloroethane. So they are saying deduce the molecular formula of the species responsible for the molecular ion peak at mass to charge 98, 100, and 102. And 102. Can you tell me? Can you tell me what's the final answer?
Yeah.
98, 100, and 102. So basically, you know, there are 2 isotopes of chlorine. There are 2 isotopes of chlorine. Number 1 is chlorine 35. Number 2 is chlorine 37. So let me tell you before going into this question. So if I ask how many peaks would be there if you are going to have chlorine which is produced, like which is introduced into the mass spectrometer, Chlorine has 2 isotopes. Maybe both chlorine atoms are of 35, 35. Maybe both atoms of chlorine are of 37, 37. This is another possibility. Maybe one atom is of 35, another atom is of 37, and maybe this is 35 and this is 37. Each and everything is positively charged because in the mass spectrometer we are going to analyze only cations, not anions, not neutral molecules. So these
Yeah.
are the 5 possibilities. So same goes in this question. Let me make a possibility of 98. You know the formula is C2. Can you tell me the molecular formula? C2H
C2H4 Cl2.
4 Cl2, exactly, and this is positively charged because we are going to determine only cation in a mass spectrometer. Then
Yeah.
I'm considering I am considering that the both chlorine atoms are of Cl 35 having a positive sign. Can you tell me the molecular mass of this? 12, 2 into 12, 1 into 4, and 2 into 35. Can you tell me the total?
$98.
Past 98. So yes, so 98 is equal to this molecular formula. This is the
Yeah.
species which is responsible for 98. Can you tell me what is the formula of the species that would be responsible for 100? Yes.
C2H4Cl35Cl37.
Exactly. This is the thing that you need to know. Yes, good. Cl35, Cl37 having a positive sign. So the peak that is 100. And then can you tell me what is 102? Yes.
102 is both of them 37.
Nice. Nice. This is nice. Yes. C2H4, Cl37, and Cl37. Okay, good. Okay. State why in both spectra the peaks are at 9800 and 102 have different relative intensities.
Because they're made of different isotopes.
State why in both spectra the peaks at 9800 and 102 have different relative intensities. So basically, this is the peak which is of 98, and what they have mentioned 98, 100 and 102. 98, yeah. This is 100, and this is 102. Am I right?
Yeah.
This is 90, this is 100, this is 102. They are saying why they have the different relative intensities. Why they have a different relative intensities. So basically, remember, this is the ratio of the isotopes of chlorine, that is 9:6:1. Basically, you have two isotopes for chlorine and you have made a possibility. Let me show you some working, that why I'm supposed to write 9:6:1. So as you know that this is chlorine molecule, and I told you the possibilities. The first possibility is chlorine 35. Then the possibility is chlorine 37. Then the possibility is 35:37. And then we have 37:35. This is 35. 35 means what? Its abundance is 75%. Chlorine 35 is 75%. And 37 is 25%, if I'm not wrong.
Yeah.
Okay, so 75% means 1/4.
Yeah.
Into 1/4. And 37 means like this is 25%. 25% means this is the 3/4 of 100. So 3/4 into 3/4. Then again, this is chlorine 35. I'm going to write 1/4. I'm going to write 3/4. Like this is 37. Then 37 is in the first. So this is 3/4 and this is 1/4.
Yeah.
Let me solve. So 1 into 1 is 16. 1 into 1 is 1. 4 into 4 is 16. This is 3 into 3 is 9. 4 into 4 is 16. This is 3 into 1 is 3 and 4 into 4 is 16. This is 3 into 1 is 3 and 4 into 4 is 16. If you can see, these are the same. 35, 37,
Yeah.
37, 35. These are the same thing. I am going to add them together. So can you tell
6
me
by
what
16.
could be an answer if I am going to add these?
6 by 16.
Yes.
6 by 16.
6 by 16. Good. So 1 over 16 ratio 9 over 16 ratio 6 over 16. Since the denominator is the same, I'm going to write down the simple ratio by cancelling. So I would be getting 9 is to 6 is to 1. So basically these are the peak ratios of the isotopes of chlorine, that is 35 and 37. So that's why I wrote over here, state why in both the spectra the peaks at 98, 100 and 102. So 9 is to 6 is to 1. Are you getting my point?